Well, good afternoon and welcome everyone to our Southern Fire Exchange and Cohesive Strategy webinar. My name is David Godwin and I'm the director of the Southern Fire Exchange program with the University of Florida. I'm joined today by Elliot Nauert, Southern Fire Exchange Outreach Specialist with NC State University. Today, we are excited to co-host our webinar with Gary Wood, Southeast Region Cohesive Fire Strategy Coordinator. And today, together, we'll be featuring a panel discussion from scientists at the USDA Forest Service Southern Research Station. And they'll be talking about methods and results related to the Southeast Region Fire Adaptation Quantitative Wildfire Risk Assessment. It's a mouthful, but it should be a fun program today. I'm looking forward to their presentation and their demonstration. So at this point, I'd like to hand things over to Gary Woods. Gary is our Southeast Region Cohesive Fire Strategy Coordinator. And Gary, welcome. Glad to be with you today and to partner with you on this program. Go ahead and take it away.
Thank you, David. And thank you to everybody that has taken time out of their busy schedules to join us today. David, it's really great to be able to co-host this with Southern Fire Exchange, and y'all do so much to help us along with all the other Joint Fire Science Exchange networks to get the science, the research down to the practitioners' hands where it's so important. This is a little bit of a map that shows our organization. We are chartered by Wildland Fire Leadership Council, and this shows our Southeastern region, which also luckily is a footprint of U.S. Forest Service Region 8, as well as the Southern Group of State Foresters region. So that works well, but other partnerships, we have multiple coverage from other regions. David showed the map a while ago, and we actually have 5 Joint Fire Science Exchange networks that cover all of the footprint of our region. Next slide, please, David. When we look at a changing landscape in our region, we have a very, very fragmented landscape that's getting more fragmented all the time. And it takes a very diverse group of partnerships and collaborative efforts to be able to work to make sure that we're implementing the cohesive strategy on the ground and making its framework work for us. Our strategy committee consists of 40 plus agencies, which you can see here. And if I left anybody out, I apologize. But during this process, I met weekly with Lars and this team, and would take information and go out and talk to people that make up this strategy committee as well as others to get feedback and input, and then funnel it back to Lars and his team. Next slide, David. And when we look at the cohesive strategy, it's based around the framework of the 3 goals of our landscapes, creating fire adapted communities and responding to wildfires. And by looking across the country, the cohesive strategy framework allows us to identify and look where we need to put the best available science we can at to make sure that we're doing the right things at the right place at the right time for the right reason. And science drives all of those decisions that help us work around that framework of the cohesive strategy so it can help all of us work better collectively, because it truly is all hands, all lands. And at this time, I'm going to pass it over to Lars and his team, and take it away, Lars.
Sure. Thanks, Gary. And I think at this point also we're going to switch presenters. So while I'm waiting for the slides to come up, I'll just say thanks to David, thanks to Gary, and the Southern Fire Exchange, and really the whole Fire Exchange network for the opportunity today to present some of our work. It's a pleasure to be here. So I'm Lars Pomara. I'm a landscape ecologist. I'm at the Southern Research Station, the U.S. Forest Service, based in Asheville, North Carolina. And I am part of a team here at the station that's been engaged really for several years now in this landscape to regional scale research around wildfire risk management and changing southern landscapes. Along with me on the team, Nick Gould, Sandhya, Nepal, Scott Goodrick, and Danny Lee. You'll be hearing from Nick and Sandhya also today. We're really going to dive into some of our research. I'm going to try to tee things up here first. Next slide, please. So we call the overall project we've been working on loosely Southern Region Fire Adaptation, and we're engaged in providing science-based decision support, information and tools. A lot of that really boils down to regional scale risk assessment work and multi-objective landscape prioritization. Now, it's really the risk assessment that we're going to be strongly focused on today, but you'll hear us talk about multi-objective prioritization efforts here and there where it's relevant. Show these kind of connections, how the assessment work feeds into some of the prioritization. And I really want to stress here on this slide the Southern Region Fire Adaptation project is really not just those of us at the research station. We do co-developed science, and that means a lot of engagement, close engagement with our partners, and our really the primary partners we work with on what we're going to be talking about today are in two flavors. One within the Forest Service, the U.S. Forest Service Southern Region, Region 8, especially Fire and Aviation Management program, the Fire and the FAM program, and the Landscape Level Integration and Shared Stewardship Initiative between the Research Station and Region 8. And then secondly, our partners beyond the Forest Service, Southern Group of State Foresters and the Southeastern Cohesive Fire Strategy. We just heard Gary team things up there. And so it's those relationships that the project really relies on for expert informed analytical approaches, helping to define really primary research objectives, as well as sort of on the end of things, our science delivery efforts. Next slide, please. So some of the research emphasis areas, and again, we're talking about these things at broad landscape scales, are especially around how and where we can better understanding how and where we can increase the scale and pace of fuel treatments, especially thinking about investments in prescribed fire. And that need points to the need for effective planning tools that help us do that. And again, tools that can address multiple goals and integrate them. So that points back to this idea of landscape prioritization around multiple objectives, especially when we're thinking about prescribed fire investments. It's a great example where we're using a tool nearly always when we're thinking about prescribed fire to advance more than one goal, right? Prescribed fire is used for risk mitigation. It's also used for ecological restoration and maintenance. So increased attention to climate change and carbon management. Of course, I think, we all understand that in recent years, there's been a lot of increased attention to these things. And you'll certainly, see where climate change and risks to from intense wildfire to stored forest carbon. You'll hear about these things today. Let's see, how are people and ecosystem services impacted not just directly by fire, but also indirectly by smoke? We know that this is a strongly emerging issue, and so you'll hear more about our efforts with risks around smoke emissions. And then last but certainly not least, increased attention to social equity and the role of social vulnerabilities in driving risk. So, increasingly we recognize that, we're thinking about fire as really a social ecological system, and there are multiple social and economic demographic factors that help shape the vulnerabilities to impact from wildland fire, right? So we need to pay increased attention to the social side of that social ecological equation. And I think you'll see all of these things touched on in one way or another today. Next slide, please. So where we're going to be going with the presentation is towards the introduction of this new online planning tool that we've developed and recently published. It's now publicly available, but not widely known about yet. Really, today is one of our first opportunities to expose an audience to it, and really appreciate it for that. It's called Wildfire Risk in a Changing Climate. This is really a collection of story maps that provide access to a lot of our data products around risk assessment, around understanding heterogeneity in southern landscapes with respect to fire and the various social and ecological characteristics that shape how we manage risk and make investments in tools like fire differently in different places. And especially the sort of centerpiece around future projections under various kinds of scenarios of change, not just climate change, but other kinds of socioeconomic pathways and so on. I do want to mention here the Southern Forest Outlook briefly. This is a decadal program and publication from the Southern Research Station that involves not just fire considerations, but a lot of other issue areas around forest conservation management in the Southern region. The last iteration 10 years ago was called the Southern Forest Futures Project. So the future projections of risk and some of these other things that involve kind of looking out a few decades at possible futures that you'll hear about today happened as part of the Southern Forest Outlook. So we contributed that to the Outlook's fire section. And I just want to acknowledge that the SFO is going to be published this year. And so that's going to be a good resource among other things for being able to take a deep dive into some of the research that you'll see us present to you today. So in order to get to the presentation of this new online tool, which Nick is going to walk us through, first we wanted to take a step back and walk you through some of the research approaches, some of the analytical approaches that resulted in the map products and other information that you see. And so to do that, I'm going to go ahead and hand it over to Nick, and then I think Nick will present some and then pass to Son. So thank you.
Okay, thanks, Lars. I'm Nick Gould, and I'm a wildlife biologist by training, and I'm also an ORISE research fellow, also with the Southern Research Station Threat Assessment Center. And I'll start by introducing our assessment approach and detailed goals. Really kind of had 4 steps to the approach, all following in the spirit of the cohesive strategy. And again, this is really a big data-driven quantitative assessment. And Gary and both Lars mentioned we use weekly working group meetings with collaborators and stakeholders to make decisions at each step, really, starting with the first bullet here, aggregating relevant spatial data from a diverse set of sources. Next, we quantify firescapes across the region using a factor and cluster analysis. And really, firescapes can be understood as recurring landscape types with particular social and ecological characteristics, such that different firescapes types carry distinctive implications for wildfire, prescribed fire, and the consequences for people and resources. Then we're going to talk about assessing wildfire risk and also the utility of prescribed fire for reducing that risk using a Bayesian network belief modeling approach. And then lastly, we're going to project changes under future scenarios, 4 different future scenarios for this talk out to the mid-century. Next slide, Sandhya. Okay, the first step towards both the firescape analysis and the risk assessment was this large-scale spatial data synthesis. We looked at 73 variables overall and really a broad spectrum of data sources to help understand regional variation in all the data, from fire dynamics and forest characteristics to socioeconomic vulnerabilities and climate. The analysis was done at the level of 1,000 hectare hexagons, which you can see in the inset map off to the right of the slide. And really, our project focused on forests. So the green areas are where each hexagon had at least 25% forest cover. And this is really because looking at the forest system is our first tier concern. Next slide, Sandhya, please. So one of the big pieces we really wanted to have as part of this project was the smoke exposure piece. And there really was no off-the-shelf available data to grab for the smoke exposure piece. So Dr. Scott Goodrick and his team out of Athens, Georgia, developed our smoke exposure layers from scratch, integrating a number of different data sources. From the NOAA hazard mapping system, we can see the inset map here. The polygons are smoke plumes detected by NOAA's hazard mapping system, and then the analysts examine the visual imagery from a collection of satellites and then outline the plumes by hand. It was also intersected with population density and then some of the social vulnerability characteristics mentioned in the previous slide. Next slide, Sandhya. Thanks. Okay, so jumping a little bit into some of the output from the factor analysis. Here we're showing that about half of that output. And we took the step again of using the factor analysis to reduce the variability in the data set down to these important factors. So we defined or named our factors based on the variables that loaded onto each of these 8 factors. And you can see those variables that were important to each factor on the side of each map in the gray. And really what's interesting about this slide is these are also 4 of the key inputs into the Bayesian network modeling that Sandhya will be talking about in a few minutes here. And these 4 particular factors, oh, hold on, next slide, sorry, Sandhya. So the 4 factor slides that we saw in the previous slide are on the left-hand side here. And just to get more of a complete picture for the factor analysis, here are the other 4 factors displayed across the region: fire history, climate and species at risk, or biodiversity, forest and carbon, and then land use or cover change. Next slide, please. So through the factor analysis, we identified 8 factors that explained nearly half of the variability in the 73 spatial data sets or variables. You can see the 8 factors listed on the x-axis in this figure in the center. And then through the cluster analysis, we identified those 9 firescape types across the region. And really that cluster analysis helps us classify landscapes and get a sense of how factors characterize these firescapes. So the 9 firescapes, you can see 1 to 9 are on the y-axis, and their shortened descriptions are in the table on the right. And just to orient a little bit, if we look at firescape 7, we can really see that that's kind of a climate factor driven by a warm and dry climate. And we'll look at the spatial layout for this factor as well, or sorry, for this firescape as well. And there are other characteristics on the right-hand side describing each of the firescapes. Next slide, Sandhya. Okay, so this is the map of the 9 firescapes together across the region with names and or short titles on the right-hand side of the slide in matching color. So again, if we just kind of follow that theme and look at firescape 7 here that we identified in the previous slide, we see its distribution is in eastern Oklahoma and Texas. This is the bright green firescape that we're looking at. Again, that firescape is really described by a warm and dry climate with mixed woodlands. But we also see places like Florida that have a much more distinctive mixture of landscape types. And then if we highlight the pink area around Atlanta, Georgia, those are our urban periphery landscapes. And you can see those highlighted around not only Atlanta, but other big cities too, like Charlotte and Raleigh, North Carolina. And this map is really our baseline when looking at future scenarios for the firescapes, which we'll start to look at in the next couple of slides. Next slide, Sandhya, please. Lars mentioned that the Southern Forest Outlook at the beginning of this talk and how it looks at future projections. And really, we did this by using the 2020 Resource Planning Act assessment core scenarios. And those really represented a range of plausible socioeconomic and climate futures. And these are really the possible futures or scenarios that we considered. Each core scenario is coupled with 4 climate GCMs or general circulation models, representing a least warm, wet, dry, and hot climate future. And we'll refer to these sort of throughout the remainder of the talk. And none of these 4 scenarios are more probable than another, but these 4 are good at representing the range of plausible GCM scenarios out there. Next slide, please. Okay, so if we look at a little bit of the output from the projected smoke exposure, we see the top map as an example with the dry climate future, looking at the change from current to mid-century and potential smoke exposure. And we see some increases in smoke exposure in orange across the region, and also reductions across the region in that turquoise color. In the bottom map, we see the potential for prescribed fire to offset climate-related increases in potential smoke exposure. And really, this map again shows strong regional variability, as you can see, with many areas experiencing small reductions in sort of that light yellow color, while other areas in blue show kind of larger potential reductions in smoke exposure. And again, highlighted in the blue box is really the key message that enhanced fuel treatment programs, specifically prescribed fire in our case, could offset these climate-related increases in potential smoke exposure. Next slide, Sandhya, please. Okay, so looking at a couple of the results for the projected firescapes, you can see on the left-hand side the least warm climate future and the dry climate future. And again, the maps are intended to show and do show the range of variability in the future climate scenarios. As an example, we'll just follow through with Firescape 7 from the previous slides. We see there's a lot of variation with Firescape 7 basically expanding east. But if you look at the paired bar plots, others show stability and considerably less change. And it's really climate that's driving the expansion of Firescape 7 here. And then if we look at the bottom right, Firescape 2, the cool broadleaf mountains forest, we can see that the brown parts around the periphery are really places where the firescape is contracting. So this would be an example of a loss of that firescape. And none of the projections really show this firescape as still present. They all suggest a reduction in this type of firescape. So the kind of the take-home message is there's lots of variability that is primarily climate-driven. And the change we do see really suggests conditions more like western and southern part of the region with warmer climate and forests more prone to fires. And these findings are really consistent with the expectations for reduced fire return intervals and shorter prescribed burn windows, at least within the traditional burn seasons of the South. And with that, I think I'll turn it back over to Sandhya to talk about the Bayesian network modeling.
Thank you so much, Nick. Hello, everyone. My name is Sandhya Nepal. I am also an ORISE fellow with the Threat Center at SRS. So I'm going to jump into the next step of our project. So our next step was to assess wildfire risk across the southern region and evaluate how that risk will likely change with future scenarios, and also the potential of risk reduction through active management, such as fuel reduction through prescribed fire. So here is the model we developed for risk assessment. Risk assessment here quantifies the vulnerability of people and ecosystem services to fire and their potential exposure to hazardous fire, with risk being an outcome where exposure and vulnerability co-occur. Here, as you can see in the figure, the potential for hazardous fire is dependent on wildfire potential and burn intensity, and they are governed by recent climate, fuel load, and many other variables. Similarly, we define people and ecosystem services at risk as people and structure directly exposed to a wildfire, people exposed to smoke emissions, forest carbon stock that could potentially be lost during wildfire events, and also important area for surface water where water quality could be compromised. So we estimated risk for each of those 4 vulnerability classes separate, and all of them combined as well. Also, since potential harm of wildfire is not evenly distributed for all the population based on their socioeconomic factors, so we also considered a social vulnerability factor here. In addition to estimating risk, our model also quantifies, also evaluates the potential for risk reduction by implementing a decision node that represents 2 different decisions. The 2 different decision choices include enhancing the prescribed fire program and not enhancing the prescribed fire program, which would be like business as usual scenarios. We also implemented a utility node here to represent risk outcome given the decision node. So those decisions would be enhancing the prescribed fire program and not enhancing the prescribed fire program. The relative utility then quantifies the degree to which outcome under one decision is more desirable than the alternative decision. Here, our relative utility of fuel reduction then quantifies the degree to which prescribed fire will be effective to reduce the risk of fire to people and ecosystem services through fuel reduction. So in our model here, you see the blue boxes here. They are all nodes for input variables. And Nick mentioned earlier about the factor analysis. We use 4 factors directly in this model. So those are the 4 factors we use directly, and all other variables are from the 73 data set we used earlier. And also I wanted to mention, like, all the data input for our analysis were spatial in nature. So and also we were able to generate spatial outputs at different level of model runs. So, we have some examples here that shows the spatial output at different steps of model running. So once we estimated risk and evaluated the utility of fuel reduction through prescribed fire, we wanted to see how the risk will likely change in the near future. So we changed the model to project future change in risk. So we use future projection data for climate. We updated our smoke variable and also updated our fuel load variable to represent future scenarios. Next, I'm going to present some results here. So I mentioned about the 4 vulnerability classes previously. So these maps here show the 4 vulnerability classes. You can see the bottom 2 maps here, vulnerable forest carbon and potential for smoke emissions. They are very correlated with each other, mainly because of heavily forested landscape. And one important thing here to mention, like in an event of a wildfire event, our study mainly focused on the forest landscape that have potential to send dangerous smoke emissions to populated areas rather than focusing just on the populated areas. So that's the highlight of our study. And also vulnerable people and infrastructure and vulnerable watersheds, they have regional distribution. For example, here, important watersheds are mainly distributed in the northern part of the study area, mainly because in this region, community depends on surface water for drinking water supply, whereas the coastal area in the southern part, people usually depend on groundwater supply. Overall here, based on this map, a higher value of higher value shows like people and resources are more vulnerable in an event of wildfire events. And these kind of maps help us to identify communities that have fewer resources to prepare for wildfire events and may likely need more support before, during, or after wildfire events. So here are the 4 individual risk maps based on the 4 vulnerability classes and the potential for hazardous fire. Just to recap here, risk here represents interaction of each of the vulnerability classes with risk factor, including fire severity and fire likelihood. So this shows the spatial distribution of individual risk. There is variation among individual risk at local to regional scales that provide also socio-ecological perspective for a fire-prone landscape. After individual risk, we also combine them. We also generated a composite or a combined risk. So you can see here in the map, most of the risk around Florida, coastal plains, eastern Texas, interior highlands, including Ozark and Ouachita Mountains, and then the Appalachian region. And in these regions, different drivers may drive the risk. For example, in the interior highlands, including Ozark and Ouachita, fuel load could be a main driving force for wildfire risk, whereas in the Appalachian region, vulnerable people may be a driving factor. Similarly, in the coastal region, climate could be the main factor driving the risk. The map here on the bottom shows the utility of fuel reduction. Overall, if you check the 2 maps here, the pattern is overall the same. There is high utility of prescribed fire in areas where there is high risk. So for example, here in the interior highlands, like we may have more capacity to reduce the fuel load through prescribed fire. And overall, where there is high utility of prescribed fire may help limit the development of hazardous fuel and also protect the communities and help them prepare for, manage, and live safely with fire. So after the current situation, we projected future risk using 16 RPS scenarios, but for the demonstration purpose, we are only showing 4 scenarios here. For warm and wet scenarios, there is negligible change in expected risk. However, as we go to extreme scenarios like hot and dry, there is an increase in risk, especially in areas where there is already high risk. And there were also sub-regional hotspots of risk increase, especially in southern Piedmont region here and the west of Mississippi River. And then more widely dispersed landscapes showing decrease in risk, like shown by the light blue areas here. These maps show here the relativity of field reduction to reduce current and future risk under different scenarios. In many areas here, shown in purple, prescribed fire can risk reduction through prescribed fire can address both current and future risk. In some areas, as shown in red here, there is modest utility of field reduction under current conditions, but shows increasing utility as we move to the future mid-century scenarios. That gives us an idea that there may be more opportunities from prescribed fire to reduce risk in the near future and also help build resilient communities. So this is my concluding slide. So the firescape classification that Nick presented and the risk assessment work here that I presented, those 2 works are complete as of now, both under current and future scenarios. And right now we are working with our partners to deliver our data and data products in an efficient way so that it is readily available to a wide range of audience. We recently published 2 methods paper for firescape classification and wildfire risk assessment. And our data that we use in our product are available through our AGOL and also through the RME dashboard. Lars mentioned about the Southern Forest Outlook. It's in the review phase right now, and we expect a GTR by the end of this year. And the StoryMap, this is in public domain now. This is a collaborative work, and Nick is going to talk more about that in the next few minutes. So before wrapping up and transitioning to Nick, I just want to mention that our next step for this project would be to develop a similar Bayesian network model for evaluating the impact of prescribed fire on improving ecological conditions. And under scenario planning framework, we plan to use a spatial optimization to evaluate the role of prescribed fire to improve ecological conditions and to reduce risk. And spatial optimization will help us analyze trade-offs among different management objectives and help us prioritize landscape where there will be maximum return on investment. So with that, I'm going to hand over to Nick, and he's going to show the story map.
Thanks, Sandhya. Everyone see the story map okay?
Yep, we can see it.
Okay, great. Thanks, David. Okay, thanks, Sandhya. I'm going to do a brief walkthrough of the story map, sort of this newly public-facing tool that we're pretty excited about. As Lars mentioned earlier, the title is Wildfire Risk in a Changing Climate, Mapping the Moving Targets of Risk Management to Help Build a Resilient Future. And this project and story map collection was really a success because of the collaborative nature of the project. From start to finish, we worked with the Southern Group of State Foresters, SouthRap, and specifically for the story map, we had a lot of great assistance from the Texas A&M Forest Service and the Timmins Group. And really it was this collaborative effort that really helped us, one, develop this and then sort of refine and polish the story map collection. So just wanted to give another shout out there to those groups. And really it is a collection of 5 story maps. You can see here on the right-hand side. And if we start looking at the first one, which is wildfire risks, I'm going to kind of slowly scroll down to the first map. There's a lot of accompanying text at the top that talks about assessing wildfire risk, as well as some of the background information that Sandhya just finished talking about associated with our Bayesian network development. And then we also, the links I think are being posted in the chat, but we also provide links to the 2 publications sort of documenting the methods for both the firescapes and the risk assessment. And really what you see, if I can sort of get, there we go. The first risk map we come to is people and structures, or population and structures. And you can see that there's, again, accompanying a text on the left-hand side that really talks about the risks to people and structures from wildfires. And then the main attraction area is the map in the center that Sandhya just finished going over. And then partnered with that is sort of this bar plot on the right-hand side that sort of looks at the total area occupied by each level of risk. And one of the neat features you'll see about that is that it sort of auto adjusts to the zoom scale that you're looking at. So as we zoom in here in a minute, this is really what this tool is about. You can examine areas of interest for the public, looking at areas around their town or their county or their states. And then managers or planners can use this tool to look at their national forest or respective management units. And I'm just going to zoom into a particular area. And what you'll see when we zoom in and it catches up here is you'll see our 1,000-hectare hexagons. And we can easily click on one of those and get sort of metrics associated with that 1,000-hectare hexagon. So it gives you a really great ability to be able to explore an area of interest. I'm going to go back up to the top in the interest of time. Below that first individual risk map was the other 3 accompanying risks, the risk from unsafe smoke exposure, as well as risk to forest carbon and forest watersheds. If we move on to the second story map, landscapes of fire, which really talks about the firescapes. And really the firescapes provide a good context for considering appropriate management. Again, we have some accompanying text about the firescapes and how they were developed at the top. We have a link to the publication associated with this work here. And then we come to the map that we saw a little bit earlier in the presentation of all the firescapes mapped together across the region. Again, you can see the legend on the left-hand side with the firescape names and their associated colors in the map. You can zoom in the same way around any area of interest that I did in the previous map. Again, in the interest of time, I'm not going to zoom in on the firescapes map. If we scroll down a little further, basically we come to firescapes 1 through 9 separately. So here we're looking at firescape 1. You can see the title for the firescape, the total area occupied by that firescape across the region, and then again, some sort of key landscape characteristics associated with that firescape, and some accompanying photos that sort of depict what that firescape potentially looks like. So again, I'll just go back up to the top and go to the third and probably the most important. This story map is really the heart of the tool, and it looks at projecting the future firescapes and the wildfire risks that we talked about a moment ago. The first part has some general information about climate, and really it highlights the need to understand the likelihood and possible magnitude and severity of fires under altered fire regimes and forest conditions. We have some specifics about the climate models that we used. And then we basically come to a nice section that sort of orients you around how to use this tool. And we come to a new map layout, which we'll see moving forward from here. And basically we have the current firescapes. You'll see in a minute, it will look very similar for the risk portion. And then we have basically the 4 projections that we talked about for this talk. And again, one of the nice features is once both are loaded, it becomes really easy to toggle back and forth between the current firescape and really give you a kind of a quick assessment of how that firescape might change in the future. And again, we can kind of see that detailed by that green colored firescape with warm and dry climate. Again, you can see the firescape profile also changes when you change between current and the 4 projections. And again, you can zoom into any area of interest that you want to explore. And then the bottom half of this is projecting wildfire risks under future climate scenarios. And again, you have essentially the same layout as the firescapes, only this time on the left-hand side in the table of contents, instead of the firescapes, you have either the composite risk, which is highlighted here, or you have you can look at the individual risk components themselves: risk to population and structures, risk from unsafe smoke emissions, risk to important watersheds, and forest carbon stocks. And again, you can kind of toggle back and forth to get a quick idea of how it may change in the future. Let's see if we go back up to, oops, sorry about that. The fourth firescape, managing risk, which has some really good background on a range of management tools that help reduce wildfire risk while supporting conservation values and sustainable uses. Specifically, we talked about prescribed fire. And as you read through the section, there are a number of other useful links and resources for prescribed fire, community planning, long-term strategic planning. And really, again, that long-term strategic planning is at the heart of this tool and the project that we just talked about. You can see the links at the bottom. The first map we come to is, again, that sort of composite risk map that Sandhya and I have both just been over in the presentation, as well as the StoryMap. Kind of a frame of reference. When we move down, we talk about and look at mapping the likely utility of fuel reductions with prescribed fire. And you can see this really represents the potential value of risk reduction that can be obtained by reducing fuels. And this map resembles the map we just looked at, the overall composite risk map. And that really makes sense because the most value is placed on reducing risks where they're already high. And then in my opinion, sort of the highlight here is, again, same layout, so it's fairly easy to use at this point. But you can look at the current utility again, or you can look at projected utility into the future under the 4 scenarios. And again, you can look at the composite risk, or sorry, the composite utility, or you can look at the utility for each of the individual components. And again, zooming into any area of interest that you want to explore for management purposes makes it really easy to do so. And then lastly, we have sort of our Explore tab. It lives up to its name. We have sort of a summary of the information that we kind of already went through in the previous 4 story maps. And then we come to a really nice one-stop shopping where we have all of the firescape projections, the risk, and the utility in one place. So it's whether you're interested in firescapes or risk, you can explore the overlap in your area of interest. And just a couple things I'll point out. You can open this up in a new page to make it even bigger. Let's see if I can get this out of my way. And the one other thing I was going to say, sorry about that, is you can't download the data directly from here. So that's why the links were being provided in the chat box, so people can actually access the data that we use for the firescapes or the risk assessment. And I think with that, I'll probably stop sharing the story map, and we can move it back to you, David.
All right. Well, thank you, Nick. Thank you, Lars. Thank you, Sandhya. And thanks for the introduction, Gary. Let me get everybody so that we can see y'all on camera here. Just a second. At this point, we have time remaining in our program so that we can get through some Q&A. We have some questions that have already come in through the chat. And so I encourage you guys, if you have questions, please put them in the Q&A tool in Zoom. If you haven't seen all the links that Elliot's been putting into the chat window during the presentation, I think most of the things that our panelists mentioned are shared in links in the chat. So look to those. And as we said earlier, those links will be shared in the YouTube description. So if you can't access them right now, we'll have those along with the recording. So I'm going to go through and see if we can get through some of these questions that we've had come in. We had one of the first questions came in while you guys were speaking and talking about that smoke hazard service. I think you mentioned that Scott Goodrick and his team were involved in developing, and it sounds like there's interest in having access to that. Is that a data layer that's accessible outside of this project, or that others could reach out to and use?
Yeah, I can take a stab at that one, Lars. You can follow up if you have more detailed information. Again, that was sort of developed by Scott Goodrick out of the Athens, Georgia office, but I believe we could make those readily available. And that's sort of the short answer to that without having sort of Scott here to weigh in on that. But I believe that could be made possible. Lars, I don't know if you want to expound on that.
Yeah, I think that's right, and I think it depends on what folks might really be looking for. But one thing I would recommend is, you know, I'm not sure right now where the links are that you guys have access to, but I believe through this webinar chat, you've got access to the links to our AGOL accessible data. Now, what you'll find in there is actually a lot more detail than what we're able to show today. Real briefly, you might not remember, but when Nick went into one of those maps in the StoryMap and he clicked on a single hexagon, and there was this big list of variables that came up with values. And you're not going to know what those are unless you go to the AGOL data sets, and we've got a detailed description. You find a table of what all the variables mean in there. And again, you can download those shape files and use them however you like in your GIS. There are some pretty detailed variables about the potential smoke exposure, potential populations potentially vulnerable to the smoke exposure, and other elements that went into the final risk results. So there's more there. And if you still didn't find what you're really looking for, then I would say reach out to us. Yeah.
All right, here's another question that came in from Dexter. Dexter is asking if invasive plant species were figured into some of your projections looking into the future, especially considering you mentioned and the role that they can have in altering fire behavior and fire regimes, particularly with grasses like Kogan grasses and others in the Southeast. Do you have a thought on or comment on that?
I can go first. If anybody else has thoughts, you can chime in. But the short answer is we have not tried to do that, and I think it would be a great research project to try and gather, you know, especially so we work at these broad landscape scales, right? And that becomes a challenge with certain kinds of data, and I'd say this is probably one, with having a good handle on the future potential distributions of a lot of the species that would be in question. And not that, you know, there couldn't be some scenario-based projections made on that level that could then be incorporated into an analysis like ours. That super interesting question, great question, and interesting research direction. And I'm sure, you know, there's work like that going on. But I guess one thing that gives me a brief opportunity to say is the project that we do have is intended to be something that we continue to update into the future. Things like, you know, we know that the recent climate that impacts our current risk assessment, those, you know, a couple of years from now, the climate data will be old, and we want current risk assessments, right? And so we want to update these things. But these kinds of considerations for improvements in the model, you know, are always welcome discussions, and that's going to be something we want to try to, you know, consider as we move forward in the future.
Hey, I'll take a stab on that one if you can hear me, David.
Yeah, go ahead.
We did talk about the invasive species and the impact pretty significantly. One of the things that the Wildland Fire Leadership Council had done a while back was signed an MOU with the National Invasive Species Council. And the big problem is there's really not a good data set anywhere that has all of the identified invasive species and where they're at. And like Lars said, from a research standpoint, there is discussions that's ongoing about trying to get a handle on mapping where they're at. And I know some of the work that Helen Moore with CAFM's Consortium of Appalachian Fire Managers and Scientists, the work that they're doing with their collaborative group has already been discussing this. And there is some graduate students doing work, I think, out of Clemson that are trying to get some mapping in that southern Appalachian area on it. But it is a big concern, and we just got to try to figure out a way to get that information and factor it in there to help us better make decisions down the road.
Thanks, Gary. Another question that we had come in, I'm going to jump around a little bit, is from Brett. And Brett's asking a few different things, but he says, do you have any specific examples for how this risk assessment could be used to prioritize fuel treatments and prescribed fire? And then he goes from that to asking about the utility of it at different scales, right? Is, thinking about the polygons that are roughly 2,500 acres each, what scales do you see this work being applied at?
I could maybe talk a little bit about the scale half of that question, and then I might ask if Sandhya, since Sandhya was talking about some of this next step prioritization effort, that might be a good one for her to field. But welcome Nick and Gary as well with thoughts. On the question of scale, I think what we usually say is, as Forest Service, we think a lot about the national forests, and that kind of scale. Of course, they all vary in size, but if we're thinking about, a ranger district or a whole national forest, I would say these are about the smallest scales at which you would really want to kind of carve out a piece of our assessment, and then within that, be looking at relative differences in local landscapes. I think that can still provide a lot of information, but of course, by the time you get down to that level, within a district, say we're talking about fairly large landscapes, and we know there's a lot of heterogeneity and pattern within those 2,500 acre landscapes, and that affects the way fire travels. Fuel loads vary. There's all kinds of heterogeneity in there, and so the last thing we want people to come away with is an idea that a broad scale assessment like this can supersede the more local expert knowledge that goes into more operational planning with burn units and those considerations, which is a whole other thing. We're really kind of zoomed out and focusing on these relative differences among large landscapes. And when we think about prioritization, certainly that's where we're thinking about these broader scales. So then from that kind of more local level, as we come out to like the level of the state, where we're looking at tribal, state and private, public, federal, public lands, and thinking about all lands perspectives. And that's, I think, where these kind of tools, and certainly this tool, really kind of come into their own. And that's very much, as we began thinking about this project a few years ago, where we were kind of laser focused was on this broader scale, where a lot of the local level information that we do have, like within a forest, we might have a great idea of the distribution of coconut grass, for example. But at these broad scales, we need a different set of tools. And I'd say, at the level of the whole state, would be somewhere where the relative differences in our data products really are meaningful for trying to consider where in this all lands approach across the state do we really see the hotspot opportunities and needs for more greater investments in fuel reductions, for example. And then, of course, as you come out to the regional scale too.
Sure, and I can add with the specific example that Brett mentioned. One of our next steps for this project is to use the data products for sub-regional studies like the interior highlands. So that is an example that we would be focusing next. Like, the risk assessment is one management goal. So we are going to add a few more management goals for the interior highlands, including short-leaf restoration, white oak restoration, those management goals, and then putting all of them into a spatial prioritization. And then that will help us, prioritize landscape, like by helping us find trade-offs, synergies between those management goals.
And that's a good illustration. I mean, that's something we're going to be working on with, our existing partners and additional partners we hope to pull in those kind of specific issue areas. That's a great example of the kind of thing that others could do too with our data, right? We're using our own data for that project, but certainly, anybody can grab our data and they're going to have different regions of interest, different questions that are driving what they're trying to prioritize. And certainly, you know, we want to be able to support and provide information for our tools towards any efforts like that others may be a context where others find our data products useful.
All right, well, at this point, it looks like we have just about run up to the end of our time today. I think we were able to get through the questions that we got into the chat window. Lars, Sandhya, Nick, Gary, do y'all have any final words that you would like to leave us with today?
I want to jump in real quick here. The question about the hazard mitigation, and I'm going to cut my video off to make sure it doesn't garble or cease, if that helps. But the question about hazard mitigation, we are in the process of updating the SouthRap wildfire mitigation portal assessment tool. And a lot of this data will go into some of that update and vice versa. So keep an eye out on that as that comes forward. And then, Wes, you mentioned about the CWDG. Before this was actually completed, Lars was able, and the team were able to work with the folks out of Region 8 Fire and Aviation Management on those community wildfire defense grants to try to really help identify some of those areas that truly were vulnerable and that needed, you know, the help there. So thank y'all for today. Thanks for the work that these folks are doing. It's been a great opportunity, and I look forward to continuing the partnership and see how this can expand and move forward.
Yeah, I think my clock's showing 2 o'clock, so cut me off, David, if we need to. But I just want to follow up on what Gary said, just real briefly. You know, major take-home points where we've been working for a few years now, real hard on these tools, and Sandhya and Nick have you know, made real strong contributions to this work, and just want to give a huge thanks to them for communicating some of this today. But as we roll out these tools, you know, I want to make sure folks have our contact, and feel free to reach out to us for questions, and, you know, potentially for data needs, things that we might be able to supply. I did want to mention that the StoryMap collection that Nick just walked us through is going to be available, you know, in a variety of places. He mentioned the Forest Service's National Risk Management Assistance Dashboard, the RMA dashboard, is one place you can kind of tunnel through to get to our data. But you know, the StoryMap collection in particular was really collaborative with Texas A&M and the Southern Group, and that's going to be linked in through and really it is part of the SouthRap online portal, Southern Wildfire Risk Assessment portal. And so it's going to be made available there. And we think really, you know, the work we've done with them kind of has helped ensure that especially the future projections of risk and fire escapes are really complementary to what the SouthRap program has been working on and providing for years now. And that's been a great opportunity for us to work with them. And again, this is all kind of complementary to and in a way a component of those tools. So another big thanks there. I think I'll leave it at that, David, but if there's anything else we can address the listener.
All right, well, thank you all so much. Thank you for joining us today. It's exciting to see where this project has come from and where it continues to grow and go into the future. I appreciate you all talking about and doing the demonstration and mentioning how this ties in with SouthRap. That was one of the questions that I had a note on my paper that came up during the presentation today. As Lars mentioned, and Gary too, we have the email addresses for their whole team on the screen. So if you have questions about this project or want to follow up with them, we please encourage you to do so, to reach out, to continue to engage and grow and connect with them.